Okay, I want to tell you that I found this problem to be difficult. All right, so I found this one to be a difficult problem. And what I found difficult was the nth partial sum. And I took some dead ends, but then I finally arrived on something. All right, so what I want to do is I'm going to go to the whiteboard, and as I do it, you know, I'm not going to show you the dead ends I took, but what I want to do is I want to certainly write the problem down. I got to look at my notes again, and I'll write down, you know, this is problem number 82. I'm going to write down what AN is. And this is going to be 1 over n plus 2 n factorial. And it's a little tedious, though. And someone said, well, why do you believe it's tedious? I'm going to start writing down, like, sums. And these are what's known as nth partial sums. So if I put an n down, and I said we start at 1, I'm going to say this would turn out to be 1 on top. It's always 1 on top. And then you'd get, let's see, 1 plus 2 is 3. And then n factorial is just a 1. So it's just 1/3. That's all it is. Now if I write down S2, it's going to be the first term, which is 1/3, plus, I got to go to 2 now. What are you going to get? 1. Let's see, 2 plus 2 is 4 times 2, because n factorial is 2. And this is like, I always say, if you add things together, maybe you lose a pattern, but I don't know what else to do. And I'll write this one over here as being, let's see, 4 times 2 is 8. 24 is the LCD. Boy, that looks bad, doesn't it? And then what do you get? You get 8 plus 3, which is 11 over 24. All right? That's kind of discouraging, isn't it? Let's put down S3. And what's that going to be? Well, I get 11 over 24 now. That's the prior two terms added together. Plus, I'm at 3 now. So it's going to be 1, and that's going to be 5. And then it's going to be 3 factorial. That's going to be 6. Boy, that looks like a tough one, doesn't it? Well, it's going to be 24 times 5, which is 120. That's not so bad. And let's see, what times 24 would give you 120? That's 5, so 55. Plus 5 times 6 is 30, so that's 4, right? And what do I notice here? 55 and 4 is 59. 120. All right, now granted, I guess I could keep going, but I'm getting kind of exhausted with the fractional arithmetic. For example, I want to write down S4 now. S4 would be 59 over 120 plus the next term up, which would be 6 times 5 factorial. You get the idea, keep going. But I want to kind of look at it. And the one thing I do notice is I believe I see something here. I believe I see the bottom is 120. I recognize that as a factorial, as 5 factorial. Let me see if I said it right. It's 5 factorial. Let me make sure that's true. 5 times 4 is 20. Times 3 is 60. Yep, 120. And I noticed that 24 is actually 4 factorial. But I want to see if I can get this thing to be 3 factorial. And the way to do that is multiply top and bottom by 2. And you would get 2 over 6. So I'm definitely seeing that this would be 3 factorial. All right? Now I'm looking at the top of this. And to me it looks like half of the bottom minus 1. 1/2 of the bottom minus 1. I'm not sure. Let me take a look at that. 60, yeah, 59. Half of the bottom, half of 24, minus 1. Is that true? Let's see. That would be 12 minus, it's 11. Yeah, that's true. Let me see if this one's true. Half of the bottom 6, right? Minus 1. Yeah, that works out beautifully. All right, so I think I got a pattern. And I'll write this over here. Sn, partial sum. Let's see, 3, 5, 2, 4, 1, 3. So what am I doing? It looks like I'm going up by 2. So I'm going to say, it looks like n plus 2 factorial. And then what's the top going to be? I got to be careful here. I'm looking at it, and it's going to be 1/2 of the bottom, n plus 2 factorial minus 1. All right? So I'm going to say that's my nth partial sum now. All right, I certainly, maybe I should clean it up a little bit, and I'll write that down for you. And by the way, I'm going to use also, I'm going to write the sum formula down now that I just did. And this is going to be n equals 1. I can't use a lowercase n now. I can use uppercase n. I'm going to stop at n of this really nightmarish looking term over here. I believe this is going to be equal to big N plus 2 factorial 1/2 big N plus 2 factorial minus 1. I do want to clean it up a little bit. And I got to multiply top and bottom by, I got to be careful here. You know what? I'm just going to split it into 2 terms now. 1/2 n plus 2 factorial over n plus 2 factorial minus 1/n plus 2 factorial. I can simplify this, and by the way, this is what's known as Sn. It's the nth partial sum. What do you get there? Well, the first term's easy, just 1/2. The next term is just simply 1/n plus 2 factorial. I'm going to claim this is my Sn, and this is part A of the problem done. I want to go back to the key, though, and see if I did a good job. And I'm definitely seeing it, all right? What's part B of the problem? Let's write that down. Part B of the problem is evaluate this. Well, this is going to be equal to the limit as the big N goes towards infinity. Same thing, of Sn. Well, let's look at that. I'm looking at this, and what do I notice? First term's always 1/2. That second term disappears quite quickly. It's 1/2. Look at the key, and they arrived at that. And we're done. We'll go on to the next question. Thank you.